Okay, this is a second video on probability where we'll actually talk about probability. We'll define a sample space, event, trial, and outcome, and then we'll be using those words to talk about probability. Okay, by the end of this video, I hope you have a basic understanding of what probability is. Okay, you also should be able to calculate probabilities of single events. Pretty simple, simple situations. Okay, so in my mind, probability is how likely it is for an event to occur. Okay, and we assign that likeliness a number between 0 and 1. Okay, events that will never happen is 0. Events that always happen is 1. And we kind of give it a number between 0 and 1 for how likely it is to happen. Now, the sample space is all possible outcomes. So if you think about flipping a coin, the sample space would be heads or tails. That's all the possible outcomes. An event is a set of outcomes to which a probability is assigned. An event could be flipping a heads or flipping a tails. Okay? A trial is thought of one occurrence of that event. So the trial would be flipping a coin once would be the trial. The outcome is the result from one occurrence. So you flip the coin, did you get a heads or a tails? That outcome is recorded as the outcome. Okay, another example, sample space for rolling a dice. So rolling one dice, the sample space would be 1, 2, 3, 4, 5, or 6. Okay, those are all the possibilities. An event could be several options. For example, rolling a 3 would be an event. You can look at the probability of rolling a 3. You can look at rolling an even number. Okay, we can look at the probability of that happening. You could do not rolling a 2. So an event is whatever we're looking at, the probability of it happening or not happening is our event. Okay, a trial would be rolling the dice once. Okay, and the outcome would be the number we get when we roll the dice. Okay, we'll be using these words quite a bit as we go on. Okay, so theoretical probability is, in theory, what we think should happen. Now, we haven't actually usually tried any examples. We've just kind of think in our head, what we think should happen. For example, for flipping a coin, theoretically, we will flip heads half the number of times. For rolling a dice, we think we'll roll 1/6 of the times. Okay, we haven't actually done any experiments or any trials. We're just thinking about what we think should happen. Okay, experimental probabilities where actually you do the event several times and you begin to look at the probability that it did happen. Okay. Now, this is kind of the foundation of a lot of the ideas we'll talk about in statistics. Now, we know that the theoretical probability of flipping a coin 50 times, you will get heads half the number of times, 25 times. But if you actually took a coin and actually flipped it 50 times, you probably won't get heads exactly 25 times. It might be 22, it might be 26, it might be 24, it might be 25. But there's some variation in that event. Okay, so we'll talk more about that as we go on. But there's a difference between theoretical and experimental probability. Okay, as you know, the probability of an event is the number of favorable outcomes over the number of possible outcomes. Okay, so what is the probability that you will roll a 4 on a dice? How many 4s are there? There's only one 4. How many possible outcomes are there? There are 6, and so it's 1/6. Number 2, what is the probability that you will roll an even number on a dice? Well, how many even numbers are there? There are 3, 2, 4, and 6. How many possible? There are 6. I always simplify my fractions, and I get 1/2, or 0.5. Number 3, what is the probability that you won't roll a 1 on a dice? We'll talk about how to talk about this in terms of the complement. We'll talk about what that is in a second. But for right now, we'll think about not rolling a 1 is a 2, 3, 4, 5, or 6. There's 5 possibilities out of 6 that are my sample space, and so I have 5/6. Okay, all probabilities, like I mentioned before, are assigned numbers between 0 and 1. Okay, it can be 0 and it can be 1, but usually it's a number in between 0 and 1. Okay, also, all the probabilities in the sample space should add up to 1. So if not, then you don't have the entire sample space. You need to go back and find. But all the probabilities in the sample space should add up to 1. Okay, and this is a picture that we'll use a little bit more. But the sample space is this rectangle. Everything that's possible. I'm looking at a particular event inside the sample space. We will call this P of S, the probability of getting in that sample space. Like I said, it's always going to be 1. Probably of some event happening. I think in these notes I'm calling it the event A. We could call it E or something else. Okay, a set of outcomes that are not in an event is called the complement of A, written A with a C up above it. Okay, so in other words, using this diagram, the complement is everything that's in the sample space that's not in the event. Okay, so for example, if an event is rolling a 4 on a dice, the complement would be not rolling a 4 or rolling a 1, 2, 3, 5, or 6. If the event was flipping heads on a coin, the complement would be flipping tails. So it's a set of outcomes that are in the sample space but not in the event. Okay, example 1. Given a standard deck of 52 cards, by the way, there's 4 suits, heart, diamond, club, and spade. 13 there are 13 cards in each deck of cards. Okay, what is the probability of not drawing a heart? Okay, well, we can think about the fact that there are 13 hearts, but I'm looking at not rolling a heart, so it'll be 1 minus. So here, 13 hearts out of 52 cards, which, by the way, is 1 out of 1/4. Okay, and I get 3/4 as my answer. Okay, or 0.75 is the probability of not drawing a heart. Okay, now it gets a little more complicated with some Venn diagrams. Okay, I'm calling this event B, event A in the sample space, and sometimes there's an intersection. So this space right here, you can see this in my drawing. This space right here where it's in both A and B is called the intersection of B. Now the symbol is one you probably haven't seen before. It's like an upside down U. Okay, the intersection of events A and B is where A and B happen at the same time. So the probability of A and B happening is A intersect B. Okay, now the probability if A and B are independent or disjoint is A times B. Okay, we'll look a little bit later of what if they're not disjoint in the next video. Okay, an example. Given a standard deck of 52 cards, what is the probability of drawing a king and a diamond? So again, this is drawing 1 card, and the probability of being a king and a diamond, I know you can think through as 1 out of 52, but using this idea, it's going to be drawing a king is 1 out of 13 times drawing a diamond is 1 out of 4. Okay, multiply it together, I get 1 out of 52, which is what we thought should have happen. You have 1 king of diamonds in the deck of cards, but that's an example. Okay, a union B, meaning it's an A or B, so it's this part, either an A or an B. A union B is having A or B happen. Okay, now to me this symbol is pretty easy to understand because it's a U, which almost stands for union. I'm not sure if that's where the notation came from, but the union of 2 events is drawn with a U. Okay, the equation is a little more complicated, but in my mind it makes a lot of sense. So if we take the probability of A, we get all of this. Okay, and the probability of B is all of this. Okay, now I've done something, and I've double counted this part, the intersection, okay? So because I've double counted, I need to take away one of those, and that's why I'm subtracting right here. I'm taking away the intersection so I don't double count that part. So it's probability of A plus B, I take out the intersection, okay? Given a standard deck of 52 cards, what is the probability of drawing a diamond or a king? Let's see here. Drawing a diamond is 1 out of 4. Drawing a king is 1 out of 13. Okay, but I've double counted, and so I'm going to subtract the intersection, which we know is 1 over 52. I'm going to use my calculator for this one. Let's see here. 1/4 plus 1/13 minus 1 over 52. And I get 4 over 13 as a fraction, or as a decimal, 0.3077. Just, in general in this class, I usually round about 4 decimal places, and that usually is fine for us. But that's kind of a rule of thumb in this class. Okay, more practice. Given a standard deck of 52 cards, what is the probability of drawing an ace and an 8? This is drawing the card once, getting an ace and an 8 at the same time. The probability is going to be 0. So there's problems like that on the homework. The practice problems have questions like that. Now, if I want to use, where it's an and situation, and so we're going to multiply. But these are not disjoint events. The probability is going to be 0. Okay, example 3. While you are riding to school, your iPod randomly plays 4 different songs from a playlist of 50 songs. What is the probability that you will hear your favorite song at least once during the week? Okay, now this is not an easy question. So out of the 4 different days, hearing your song at least once means it could be once, it could be twice, 3 times, 4 times. And it is random, right? So it could happen several times. So at least once. When there's questions like at least once, it's often usually easier to think about the complement of the event than the actual event, okay? Because the complement of at least once is not happening at all, which is fairly easy for us to think through the fact of we're looking at 1 minus the p of not hearing it at all. Okay? Now, the probability of not hearing my song at all is out of the 50 songs, I have 49 out of 50. So all the other songs on the first time, and the second time, and the third time, and the fourth time, that's the first day. And I would do that for all 5 days. So I'm going to use some exponent notation. This would be 1 day, okay, the 4 songs. And I have 5 days. So I'll actually change this to this times 5 or 20. Okay? So 1 minus 49 out of 50 raised to the 20th power. And I get 0.3324 as my answer. Okay, now this is just emphasizing the fact that the complement is a really powerful tool, especially when answering questions like at least once. Those questions, the complement is usually a lot easier to work with than the actual event. Okay, at this point, I want you to go through the notes, go back over the video, summarize the big ideas in this lesson to help kind of synthesize what we've talked about in this class. Also, try the practice problems that are with this video.